For this problem, we have an absolute value equation. Remember that the first step for an absolute value equation is to isolate the absolute value. So the first thing I need to do here is to add 3 to both sides of my equation. So I'm going to add 3 to this side of the equation and also this side of the equation. That'll leave me with the absolute value of 2x plus 5 is equal to 3. Now once we have it to this point, we need to make 2 separate equations, because remember, in order for this absolute value to equal 3, this inside stuff could be a 3 or a negative 3. So we set up 2 equations like 2x plus 5 is equal to 3, and we also set up 2x plus 5 could equal negative 3. Now all we do is solve these 2 equations, and that's our solution. So I'm going to subtract 5 from both sides for this problem, and that's going to leave me 2x is equal to negative 2. And then I'm going to divide both sides by 2, and I have x is equal to negative 1. So that's the first part of my solution. The other part is going to come from this other equation. So I need to solve this equation over here. And to do that, I'm going to subtract 5 from both sides. And that's going to leave me with 2x is equal to negative 8. And then I'm going to divide both sides by 2. And that'll leave me with x is equal to negative 4. So my 2 solutions for this problem are x equals negative 1 and x equals negative 4. The solution of this absolute value equation was x equals negative 4 and negative 1. We're asked to graph this on the real number line, and to do that, we just put points for each of those solutions. So this is the graph of the solution of this absolute value equation. Now again, since we only had 2 solutions here, this is a conditional equation because it's only true sometimes. So this is a conditional equation.